In this video, we're going to talk about how to multiply radical expressions. And to understand that, we need to understand the property that the square root of a times the square root of b is equal to the square root of a times b. Notice that these are both square roots right here. And also the a and the b aren't necessarily, they're not the same. So when we're multiplying, we don't need to have the same numbers inside the square root. So if you have the square root of 6 times the square root of 15, that would be the square root of 6 times 15, which is the square root of 90. And at that point, you would also want to see if you could simplify that further. That could be written as the square root of 9 times 10. And the square root of 9 is a 3, so that would be 3 root 10 for your answer. So let's practice a few of those. The square root of 6 times the square root of 10 would be the square root of 60. And then again, we would look at our list of perfect squares here for what goes into 60. And 4 goes in there 15 times. So you would write that as 4 times 15. And the square root of 4 is a 2. So I bring that out front, and I have 2 times the square root of 15. Now here's an example. We have 3 times the square root of 2 times the square root of 10. So basically the rule is when we have a combination here, you multiply plain numbers times plain numbers and then the roots times the roots. So you have 3, and then root 2 times root 10 is 20. And from there, we look if we can simplify, and the square root of 20 has the factor of 4. So we would write it as 3 times the square root of 4 times 5. And the square root of 4 is 2, so that has to come out front. So we have 3 times 2 times root 5, which would be 6 root 5. Here's another example. Again, we have a combination, so then plain numbers times the plain numbers would be negative 14, or I should say integers times integers. And then the square root of 3 times the square root of 6 is the square root of 18. From there, we want to simplify the square root of 18, so you have negative 14. And then what goes into 18 is the perfect square? 9 times 2. And that equals 18. And then we simplify. The square root of 9 is a 3, so that comes out front. And we can multiply then. Negative 14 times 3 would be negative 42 times the square root of 2. And here's one more example. Now this one we could do this a few different ways. Again, we could do negative 7 times 2 and square root of 9 times square root of 7. But if I recognize here the square root of 9, that's a perfect square right there. So I can take the square root of 9. It would be negative 7. The square root of 9 is 3. And then I have times 2 and then root 7. So now we just multiply the integers in the front. So we have 6 times 7 is 42, so it's a negative 42 root 7. Just a few more examples here. Let's talk about when we have to distribute with just a regular problem that we're used to. We have 12x minus 54. And sometimes we will have it inside an expression here where we have to distribute, and then we have to continue by combining like terms. So here we would have negative 6x squared minus 10x plus 3x. And at that point, we combine like terms. So that is our final answer. So lastly, let's do a couple more examples here. Now we're going to distribute with roots. So again, I like to draw those little bubbles there to just help me know where I'm going here. So the first of all, I have the square root of 10 times the square root of 3. That would be the square root of 30. And then square root of 10 times negative 3 root 2. So remember, multiply the plain numbers times the plain numbers and the roots times the roots. So you have negative 3. And root 10 times root 2 would be root 20. And then I just do have to go through again and simplify. So the square root of 30, there are no perfect square factors in that, so we leave it. And then root 20, we can again break that down to 4 times 5. And the square root of 4 is 2, so we take that, bring it out front. And then we have root 30 minus 3 times 2 is 6, and then you have root 5. So there's your final answer there. Here's another one. So we have 3 times the square root of 10. We usually put the integer in the front. And in the next problem, we have minus 3, and then the square root of 10 times the square root of 10 is square root of 100. So we can continue by simplifying, and we have the square root of 100. That's actually just 10. And so we have 3 root 10 minus 30 for our final answer. Couple more examples here. So here we have 5 times the square root of 3 times the square root of 3, or the square root of 3 times the square root of 3 is the square root of 9, plus, all right, here we have 5 times 5 is 25. Multiply the plain number times the plain number. And then the square root of 3 times the square root of 10 is the square root of 30. And we want to look through here and simplify anything that can be simplified. In the square root of 9, that's a perfect square. It equals 3. So we have 15 plus 25 root 30. All right, and we'll do one final problem here. And again, we have some options here. We could distribute, or we could look through here and say, oh, the square root of 4 is 2. So before we even start, we might want to say, well, that's 2 times 2 plus 6. So we have root 3. And then 2 times 2 is 4 plus 6. And remember our PEMDAs, we want to do our simplify our parentheses first. So we would have root 3 times 10, which is 10 times the square root of 3 if we just put it in the other order. Now, with that same problem, we also could have just distributed first. Let me move that up here. And so we would have 2 times the square root of 3 times the square root of 4 is 12. Plus 6 times the square root of 3. And at that point, we look at our perfect square factors. That would be 4 times 3 plus 6 root 3. And the square root of 4 is a 2. So we bring out another factor of a 2. So we have 4 root 3 plus 6 root 3, which is 10 root 3. So either way, you get the same answer. But whenever you can simplify a perfect square, you should do that.